My name is vandenEnden, and this is my midterm presentation on an active vision stabilization apparatus for the AERO4842 Spacecraft Design class with Professor Ellery. Many optical sensors are often present on planetary missions, but because they require stability for consistent exposure to obtain useful data, and because a Europa probe in this case will be suspended in fluid and subject to vibrations and drifting, an active control system needs to be implemented in order to obtain usable data. One strategy for achieving this is called active vision, in which camera images are processed using machine learning to obtain information about the environment through multiple camera viewpoints. In the case of this project, a single camera will be used by utilizing a controlled active vision framework, and then adaptive control techniques must be implemented to control the robotic actuators in lieu of having multiple viewpoints. So here's a basic system overview of the system, where a camera observes the specimen in discrete time. Tensorflow observes the location of said specimen and sent to a controller, in which a signal is sent to a servo amplifier, which amplifies a PWM signal to servo motors controlling them, moving a camera mount, and pointing and controlling a camera. These electronic components were all ordered, assembled, and tested, and are presented here, where a camera is connected to a Raspberry Pi, the computer, which sends an I2C signal to the servo controller, which ultimately amplifies a PWM signal to the servos. The Raspberry Pi runs a software written in Python, which implements TensorFlow for image recognition, converts this to coordinates, and then sends these commands to a PID controller and later an adaptive controller, and converts this to commands, which is sent through an I2C serial bus, ultimately to the servo controller. TensorFlow is a machine learning platform that's easily integrated with Python, and it was used because many trained models for computer vision are already commonly available for this exact application. Many resources online already exist for object tracking using 2 or 3 degree of freedom camera pointers. And so I'm going to be using that as the basis for my 6 degree of freedom system. However, when I implement 6 degrees of freedom, it will implement inverse kinematics and adaptive control procedures to replace the simple PID and simple 2 or 3 degrees of freedom. Presented here is my project timeline. At this point, I've completed conducting research and constructing a system overview, ordering components and assembling and testing components, and from this point forward, I'm going to continue with implementing my computer vision, writing my control software, constructing the final 6 degree of freedom robotic manipulator, and ultimately implementing the adaptive control system. So these are my resources that I used in this presentation, and thank you.